Okay, so I think it's better. So as I said, no, thank you for coming. I think Diego, the session is completely for you. You are here in the big screen. We have the microphone. We can see you. I think you can see the people.
Yes, I can see them. Yeah, hello everybody. Well, we are good to start. It's 7:07, so I think it's time to start with this swift introduction session. Okay, everyone hear me? I can see few computers. I really love when when I go to a workshop that people doesn't hear me. What I really like is people writing code and people trying things. So if you have your computer set up, I will be more than happy if you try to write some code with me, because the idea here is to try to learn as a group, not some kind of expert trying to give you best practices or something like that in Swift. But if you don't have a computer, that's okay. I will show. I'm going to use a presentation, a keynote I have right here, just to order my mind, because I tend to I'm not the most focused person in the world. So I think I will need some kind of presentation to get me throughout this hour or hour and a half. Well, let's start. I'm going to change to my presentation right here. Now you can see the presentation. If at any time you don't see something, the size of the typography is too small, or you can see the code, or I do something too quick using, for example, my keyboard or something like that. If you don't see or don't understand anything, please stop me. Shout out loud and try to get noticed so I can explain that thing for you. Well, the presentation, I think it's in Spanglish. Parts are in English and parts in Spanish. Don't ask me why. I've been writing this presentation, and sometimes I feel like writing in English, and in other times I feel like writing in Spanish. So, well, who I am. My name is Diego. My Twitter handle, if you do that thing, is Diego Freniche. I'm an app developer. I develop apps these days mostly for iOS and Android, and I teach people how to develop apps. So if you can have a look at my CV, it's on GitHub, so it's on that repository. But this is not the interesting part. The interesting part is this one. Swift. Swift is a language that has been in development most probably for the last 4 years. Its creator is Chris Latner, who is the lead of the LLVM compiler, and is based in C, in Objective-C, and in other languages, but is not backwards compatible with Objective-C or C. The syntax is different from what you can see in C, and is different from the brackets that you can find in Objective-C. So it's a new language, and it's a new language in which you are going to find lots of little parts of several languages. For example, you are going to find things that will resemble you a JavaScript, or will resemble you C, or will resemble you Haskell, or so it's a modern language that is copying. Yes, it's copying. It's based in new ideas. So I think no one will be surprised that if you are going to create a new language now in 2014, you are not going to invent anything. You are not out in a void, and you are going to be based in the existing languages. Why Swift appears now? Because Objective-C is a fairly old language, and it hasn't been that much used until 2008, more probably, when the iOS SDK came out. Since then, Objective-C has been changing, has been trying to keep pace and trying to get more modern, but there were several things that hold Objective-C back, mainly C++ compatibility. So Swift is a new language, doesn't have to be compatible with C++, which is, at least it looks for the compiler makers, a good thing. And it offers a modern language in which most probably the iOS and Mac development will be based in the next 20 years. Well, what do I have? If I have existing projects for iOS or Mac, or new projects? Well, for existing projects, it's clear. If you have a project with an existing code base written in Objective-C, you are not going to rewrite the whole thing just for free and for fun. That's plain stupid. Because it will be a waste of your time and your energy. If you have an app and it's good written in Objective-C, just maintain it. I think there are 1,200,000 apps in the App Store right now, or something like that. It's a huge number. All of these apps are written in Objective-C, and they are going nowhere. So Objective-C is not going to disappear from one day to another. It's going to be here for many, many years. So this is going to be, I think, a slow and paced transition. Maybe for new projects that you will target to launch in 2015 or late 2014, maybe for this kind of new projects, you can think of write the whole thing in Swift. But be warned, Swift is not a finished language. So we are not yet in version 1.0. So if you are looking for something established, mature, something that is not going to change, then Swift is not for you. Swift is now some kind of an experimental platform. So what do we need to write code with Swift for iOS 8? Well, we need Xcode 6, which you can download if you are a paying registered Apple developer. And we can use a tool new with Xcode 6 that's called Playgrounds. This year we have a relaxed NDA. You know, Apple, when you enroll with Apple as a registered developer, you have to agree with a non-disclosure agreement, which is a little bit draconian and doesn't let you show whatever is new in the tools. So this year Apple is being a little bit more flexible with the NDA. So I'm going to show you the Xcode 6 app. Here I'm going to change my screen. Just a second. I'm going to change my screen to my applications folder. That's my applications folder, as you can see here. I have Xcode 5 installed. This one is Xcode 5. And I have a bunch of betas right here. Xcode beta 3, 5, and 6. I don't know why beta 4 is not here. Maybe I deleted it, because each of these betas eat up like 5 gigs of space or something like that. So I tend to delete every new version. But here I'm going to use, today I'm going to use the Xcode 6 Beta 6 app, which it happens to be launched right now. So you can, the idea from this folder is that you can have the Xcode 5 app and the Xcode 6 Beta apps side by side in the applications folder. At the end of the day, an app is just a folder in Mac. So if you want to have several versions of Xcode installed, you just have to rename them, and there will be no conflicts. You are not going to overwrite anything. So having that in mind, that I'm not going to destroy anything, we are going to start changing again. In real life, this is a little bit more, more fun. I'm going to change again to my slides. You have, as an official documentation, 2 books from Apple, the Swift programming language and Using Swift with Cocoa and Objective-C. These are 2 big and well-written books that I really recommend you to read. They are free to download. You don't have to be a registered developer. They are right there in the iBooks app, so you can download and read it in your iPhone or iPad or whatever. Also, there are lots of blogs and people making training materials right now. So I think we are going to be well covered for training materials in the case of Swift. Well, Swift is based in several programming paradigms. You have imperative programming. You can create variables and make ifs and make switches and make fors. We are going to see all of them. And you can make object-oriented programming. You have generics. So Swift has generics like C# or Java. And we have some tools from functional programming. In this session, I'm not going to talk about functional programming because I think this is an intermediate or advanced topic for people who hasn't been exposed to a functional language in the past. If you are used to develop, recursive functional procedures in Haskell or Lisp or JavaScript or Ruby or whatever you call it, this is going to be all hat. But for people who came from Java, for example, which are not used to functional programming, well, I'm not going to touch this one. So we are going to talk here about imperative programming, object-oriented programming, and generics. So let's get started with a playground. So let's get started with a playground. I'm going to change my screen again to Xcode. So I'm going to switch to my Xcode, which is not open. Now it's open here. So I think I can change to... I can't change to Xcode. Well, I'm going to create a new playground. When you launch Xcode for the first time, you have a window. And you have there, the first button is Get Started with a Playground. So I'm going to press it, and then I will try to... Well, I'm going to share my whole... I'm going to share my whole desktop. I hope you can see it well. Here, I'm going to create a playground, which I'm going to call it Hello Swift. It's Hello World. The platform I'm going to develop for iOS. We can switch to OS X, but I'm going to use iOS. Hit Next, and then I'm going to create this playground in a folder called Ironhack in my desktop. Okay. Once we have our playground created, I will try to show only that window now, if that's possible, or Hangouts. Yes. Can you see in the code? Can you read properly the code? Thumbs up. Thumbs up. No, it's too small.
Yeah.
Yeah, I'm going to change. And now?
Yes. Yeah.
It's better?
Yes.
It's better, yeah. Thank you. Thank you for your feedback. So I'm going to change here the main tool for learning Swift. That's a playground. Until now, Objective-C and C++ has been languages which you have to compile prior to see the effects of changes in your code. You don't have a C interpreter or a Objective-C interpreter. Even being a dynamic language, you have to compile Objective-C code in the past. But this is not more with Swift. With Swift, we have what is called a REPL. We have a REPL, which is a read print, a concept which is familiar for people who is doing any kind of functional programming. This is an interpreter, and you don't have to even hit the run button. It's always interpreting your code. So we can see here that in Swift we have normal comments, like in C or C++. You here have a one-line comment, or you can have block comments. You can even nest block comments, which is a very welcome. This is because sometimes you just comment out a block of code, and then you try to comment a bigger chunk of code who contains the first block, and this doesn't compile in C or C++. And in Swift, this is for if you want to add comments to your code, you're welcome. That's quite easy. And then we find here the first C-like syntax. This import UIKit is importing all the UIKit module. The modules in Swift are kind of the packages in Java. So here a module is acting as a namespace. So here we are getting access to every single class and interface we have defined inside the UIKit module. Okay? UIKit, by the way, is the framework that is used in iOS to make all the buttons, all the images, all the user interface. And that's the reason it's called UI User Interface Kit. If you doesn't understand anything, any of you, if you don't understand anything, please stop me and I will repeat. Well, here we are defining our first variable. As you can see, here in Swift, to define a variable, you use the keyword var. This is like in JavaScript or in Pascal if you are older. So you use the var keyword to define, for example, an integer number, or if you want a float, you can define a floating point number, or you can define whatever you want. You can see here what is really needed. You need to put the keyword var. Then this is the identifier of your variable, and then you can pass a default, or you can initialize your variable using a first value. In this case, I'm using a string. As you can see, we are not telling here to the compiler the type of our variables. So you can think that Swift is dynamic interpreted language, like for example Ruby or Python, where you don't have to, or JavaScript, where you don't have to tell the compiler exactly of which type is every and each variable. Well, this is not exactly true. The compiler is very clever and is doing a thing called type inference. So the compiler here is seeing that I'm putting a string inside the variable called str, and it knows I can't put a number, for example, inside str. If you try to do that, you are going to get here a compiler error. You can only assign here strings. For example, I love type int. Now Swift is a strongly typed language. The compiler does type checking, but the compiler doesn't force you to write all the type information. It's clever enough to let you avoid that boring task. So you can define a string in this fashion, or you can define a string, for example, name, using this more complex form, in which you are telling the compiler this is a variable, it's called name, it's of type string, and I want to put inside Diego. You can see that anytime you made a change, the REPL, the read eval print loop, this is not in the right order, the read eval print loop is showing us here the values of these variables. And since beta 6, I think, if you try to print any of these strings, it's going to show here, right here, what is printed on the console. So I'm going to print. To print anything on screen, you use print ln. So this print line is taken directly, I think, from Pascal. I don't know if in other languages you have print line, but I remember it from Pascal. Maybe this has been copied in other languages. So if I want to print a string, I just have to print the string. As you can see here, you get here what is going to be printed on the console. You have here directly to inspect it. So you can print again, for example, my name, which is Diego. And what happens if I want to print? Imagine I want to print I love type inference and my name is Diego. It looks like the correct answer here is to concatenate the strings, to use the plus operator, and to write something like that. I love type inference and my name is, yeah. So as you can see, this is not Objective-C anymore. You can do this thing, which is old hat, and you can do it, for example, in Java since the very beginning, or in other languages. But for Objective-C programmers, this is a real boost. This is a real novelty. Well, we have seen how to print concatenating strings, and now imagine we want to print something like Diego is 25 years old, which, as you can tell from my pictures, is complete true. Yeah. So I'm going to print this thing. And to print this thing, you can think, well, this is going to be like in Java, for example. I'm going to print name plus is plus 25 plus years old. And you are going to find that this thing is not working. As you can see here from the output, this is interpreting okay the concatenation of a string name plus is working, but when it encounters the 25, which is a number, the compiler freaks out and stops and tells you this is a number and I don't have an overload for the plus operator to concatenate a number and a string. So in Swift, to do this kind of things, we don't use the plus the plus sign. In Swift, you can overload operators. So in the future, that is in 2 hours time, you can go home and try to create a plus sign overloaded using a string and a number that works, that returns the right string. But here we are going to use what is called string in, which is a fancy name to say that we are just going to put the 25 inside here. We want to put the 25 right here, but we want to change this 25 using, for example, the variable called n. Well, imagine you are digging here a hole. So you are here cutting a hole in your string. How do you mark you are creating here a hole? Well, you mark it with this syntax, and here you are telling the compiler, hey, I want here a place to put a variable, and the variable I want to put here is n. Yeah. So if I change, for example, n to 25, I have the desired result. Everyone school? Everyone school by here? Yeah. Is that until now? This is quite easy. So this thing called string interpolation is a little bit weird, but it's an advance from what we have in Objective-C. In Objective-C, we use those funny percent sign S, D, or at from the C days. So believe it or not, this is a real advance from Objective-C. So, any questions until here? I'm going to advance. So as you can see, I'm writing code here in my playground, and this code is in what is called this is global code. This code is not inside a class, it's not inside a method, it's not inside a function. It's right there in, with global scope. So in Swift, you can start writing code without having to put that code inside anything. This is quite good, especially in playgrounds, to try little bits of code, to try functions, to try, for example, how to convert data or how to convert something. And when you have your code right, you can then copy and paste in your real project. Okay? So you don't need anything to start writing code, just start writing. You don't even need that import. that import is going to be useful if we use any of the UIKit classes. I'm not using until now any of the UIKit classes, so I can even get rid of this import and everything still works. You don't need to put semicolons at the end of every line, but you can put them if you like it. So you can put semicolons, but the semicolons are optional. So it's up to you to put semicolons in your code or just leave it without semicolons, like in Python or Visual Basic or something like that. For C programmers, not using semicolons is hard. I think if you've seen other languages, this is not a big deal, but for many people, this is going to be a real boomer. Advancing, we are going to use variables a lot, but in our code, we are going to use in Swift many times. We are going to use constants. To define a constant, you use the keyword let. Yeah. So if you are like me in your 40s, maybe you remember let from the Spectrum Basic. Maybe or maybe not. But to define a constant, you define, for example, let p be 3.14, yeah, and you now have a constant called p, yeah. So as this is a constant, you can't change to any other value. You are going to get a compiler error, and in Swift code, you are going to see lots of time code using constants in place of variables. Why? Because debugging code which mutates a state, it's really hard, and most of the problems we have when debugging object-oriented code is because of some object mutating, changing its state, changing its data when we don't want it, or when we don't when we don't expect the object to change. In functional programming, in the functional paradigm, you don't mutate data that much. It's better to pass data to a function, and this function calculates new data, but doesn't change the data you've passed. So you are always on the safe side. Yeah. So you are going to see these let statements a lot. So if you have something you want to print, for example, this is my pattern string. The preferred way to create the pattern string is, using the let keyword. This is a pattern. I'm going to put here a comment, and if I want to print this thing, I'm going to use print line using, for example, pattern string. And this is going to be print well enough. You can use print line or just use print. If you use print, it prints but doesn't send carriage end of line and carriage feed or whatever it's called. Yeah, it doesn't change to the next line. So here I can use and print, for example, pi. So most probably you've seen in Swift that Swift is famous for using Unicode for the name of the identifiers. You can create identifiers in Swift using Unicode. In Spain, we had for decades, some debates going on about if it's better to develop in English or in Spanish. The main reasons for developing English is that this kind of things are really ugly. Yeah, but now as Swift supports Unicode, you can do this thing at last if you like to do this thing. I don't like to use Spanish in my code because I don't assume everyone in the world is going to understand Spanish, but English is the lingua franca for development. So I develop everything in English, or try to develop everything in English, and I'm not going to use the ñ or or something like that, which is quite shocking because you haven't been able to do this thing in in any programming language I remember, and now you can do this in Swift. You can use all Unicode characters, so you can use Japanese, for example, or Chinese, or Russian, or you can use any Unicode symbol. You can use obviously emoji, and I know the people is using this thing to make a little bit of fun, yeah, because you can have a variable called horse head, yeah, and then you can print horse head, which works, and you can have classes called, for example, happy face, and you can have a method called beer or something like that, but with the emoji representation. You can use all emoji characters. I don't think this is going to be useful. This is fun, but this is not going to be useful. But one good thing of the Unicode, besides the ability of developing in Spanish, is that you can use, for example, this thing. And if you use for P, you use P, maybe it's more easy to do this kind of things. Yeah. Maybe these formulas are more understandable using a Unicode character. Okay, so you can use emoji everywhere. I have here some fun examples. I'm going to change to some fun examples. I don't know if you can see them, but basically it's the same idea. You can use whichever emoji character, for example, for true or false, or to do. You can even do a for loop. You can iterate an array or a string of emoji characters, and you can concatenate them. So you can use emoji as any other identifier. Okay, enough emoji. We are going to change again to our playground because we have bigger fish to fry than emoji. And here we are going to start talking about, for example, arrays. I think we need a good array. To define a simple array, you can create, for example, an array with the names of the four Marx brothers: Rocho, Harpo, Chico, and Seppo. This is the last one, and no one seems to like him. So it's not that well known as the other three first. Well, we have here our Marx Brothers array, you can see I'm not telling the compiler this is an array of strings. Yeah, I'm not telling the compiler anything. But if I try, I can use the array as expected. You can use, for example, Marx Brothers 0 is Groucho. Arrays in Swift start in 0 and end in size -1. So this is the last one. If you try to access, you are going to if you try to access to an index which is not covered here, you are going to get here a compiler error. This is really an exception, which is telling you are out of bounds. So I'm going to go back to the 0 and 3, and this is a constant array, meaning I can count, for example, the number of elements in the array, but I can append new elements to my array. As you can see here, this is a constant array, and you can't append new elements to this array. If I change this array from a constant to a variable array, then boom, can append new things here, and the count is going to change. Yeah? Everyone is cool? Yeah, thumbs up. You are getting the ideas. Yeah. Well, I'm happy then. So let's go. You can define arrays here without telling Swift the type, but also you can also tell Swift that this is an array of strings. To tell Swift this is an array of strings, you are going to use generics like in Java or C#. And in this case, the syntax is exactly the same as in Java. I'm getting here and Barmas Brothers. This is an array. I'm sorry. This is a string. This is a string array. I'm not getting here the right. I'm sorry, but it's vacation time, and I'm not. I'm not that trained. So I'm going to check out the syntax if we are going to make a 5-minute break or something like that, and I'm going back to that. So here. I'm not going to show you the syntax to define the strings. I'm too bad to remember these things by heart. I'm always forgetting them. I think this one, yeah, array of strings, yeah, this is the right one. So here you are telling the compiler this is an array that contains all these strings. Okay. So you can put here any class, you can put here your own classes, and this is a type array. You can put inside the array, for example, you can put, a float number of 10, something like that. You can put this thing, because float is not a string, yeah? You have to put here strings. So, at last we have the power of generics in Swift, which is about time, because we had these things in Java or C#, well, a long time ago, since 2003 in C# and 2005 in Java. So, well, it's a very welcome addition. Well, we have arrays, and we can create another thing that are called dictionaries. In Java, they are called maps. Here are called dictionaries. Dictionaries. A dictionary is a pair of keys and values. Yeah, you have pairs of key and value. Yeah, so this is more correct. You have many pairs of one key and one value. So to define a dictionary, you only have to write the dictionary. You don't use a special syntax. You use the same brackets as we were using for the array, so it's easy to remember. And then you just use a key, for example, Gro for Groucho, and then you can put Marx Brothers 0, and then the next one, Groucho and Harper, for example. I'm going to put here only 2 of them. Then you can access your dictionary using your key. For example, har is going to show you here you have an object that contains harple. As you can see, when I move my mouse from line to line, the REPL is showing us here in this part, in the red part of the screen, is showing us the values that are going to be printed or that the REPL is computing. But here I have 2 buttons. I can press the quick look button here, and you can see the structure of your array here with all the index numbers. Here you can press obviously in the dictionary, and you can see the dictionary contains just 2 elements, and you can expand this thing and have a look at the key and the value. Okay, and you can even go and quick look any of these values. Yeah, we are going to see just in a minute that this quick look is really powerful. Yeah, well, we've seen arrays, we've seen dictionaries. Well, what if we want to create some reusable code? You know, a method, a function, something like that. In Swift, you can write what is a method in other languages, or a function. You can create functions just using the func keyboard. Yeah. So I can create here a function called print hello world, and this function is going to just print, obviously, hello world. As you can see, you can define a function without having to create a class beforehand. There are languages like Java until the 8th version where you can create this kind of first class functions. This is called a first class function because this function can stand in its own. This function doesn't need to be inside a class. You don't have to define first a class and then create a method and then instantiate an object of that class to call that method. Here you can just write the code and call that code. If you came from Python, JavaScript, or Ruby, this is the obvious thing to do, but remember, in Objective-C, things were a little bit different. So if I want to call print hello world, I can just use here, you can see it's here, yeah? So I can here invoke my print hello world function. You can see it's not printing anything here because this print hello world function is not returning anything. So this is a function that has no parameters and doesn't return anything. What if I want a more flexible hello world function? Call, for example, print print word. If I want a function called print word and I want to pass here some parameter, I'm going to define here, for example, that the word is a string, and here I can use my string interpolation techniques I was using a few lines up here. So now we have a function which doesn't return anything, it's returning nothing, but it's getting one argument. In Swift, you pass arguments using a list of arguments. This list of arguments is more complex and powerful than in other languages. Here I'm showing you the most, the simplest of the syntax, which is the name of the parameter or the identifier of the parameter and the type. But things can get real complicated up here, as we are going to see in a moment. Well, here I have my print word, and I can use print word, and pass a word, for example, hello. And this is going to print hello and hello. In this case, it's going to print hello, hello. The REPL is not printing here. It's not printing here in the function, but I think it's working. Well, how do we return values from functions? Well, I'm going to create a function. I'm going to put it at the very beginning. I'm going to create here a function to add two numbers. Okay? I'm going to create a function, add two numbers, and I'm going to pass n1, which is an int, and then oh, not this one. This one is better. Yeah, so I want to return, obviously, n1 plus n2. Yeah, I want to return the result of n1 plus n2, and I need to tell the compiler that this function is going to return an integer. To do that, you don't put here the type. You don't write here int, for example. What you do is you use an arrow, and you tell here, I'm going to return an integer. Yeah? So this is the syntax we use in Swift to tell the compiler what is the type of the data we are going to return from this function. And now, for example, use add two numbers. And if I put this thing in y equals add two numbers, y must compute to 20. My REPL is broken. It looks like my REPL is broken. You know, we are using a beta version, and the playgrounds tend to crash. They are buggy, but they are improving. In 2 months' time, they've changed a lot, but still there are some times where you don't get them to work, and you have to close the playground and to reopen it. So in this case, I'm going to go ahead to explain more things about the functions. Here, I can add two numbers, but imagine I want only, or I want to divide numbers. Divide numbers. Yeah. You have here a numerator and the denominator. Yeah. and you are going to return another number, yeah? For example, int. Imagine you are passing here in D a 0. What's going to happen if I just return this thing? If I do the thing and then use divide numbers and doing 0, this is going to crash. Yes? In these cases, you can return a special number telling that this is infinite number, or telling whatever you want. But you are really returning a special number because your language doesn't let you return more than one thing from this function. Because if you could return more than one thing from this function, you can return a number if everything is right, and if there's an error, you can return, for example, 0, and tell in a flag, hey, here is an error. Yeah. In Swift, you can return more than one value from a function. So you can return what is called a tuple. This is a pair of values. You can return 2 or 3 values or whatever you want, and you can return an int and a boolean. This bool is going to be called error because you can name the return parameters. I'm going to move this thing, yeah, so you can see this thing in all its glory. So here I'm going to return, and there's no error, so everything, no error, is false. Everything is fine. But I'm going to return this thing in the case D is not 0. So if and now in C languages you will write this: if D is 0, you are going to return 0, and there's an error, true. In Swift, the parentheses are optional, but the curly braces, these curly braces are mandatory. So you can get rid of the parentheses, but you cannot delete the curly braces, even if you have only one statement. If you have only one statement in a for loop, in a while loop, in a do-while loop, in a switch, in an if, you have to put always the curly braces. The compiler forces you to put the curly braces, which for me is a good idea. You avoid silly errors of thinking some code is executing where it's not executing, or it's not inside the block. So here you have it. Here you have a function in Swift. It's not inside command set. It's not inside any class. So it's a function, a first-class function. It's a function that works on its own, and this function is returning a tuple of values, 2 values. In this case, it's returning the value from the computation and if there's an error or no. And you can use divide numbers, assign it to a result, and then ask the result how cool is that? Yeah. You are falling in love with this. Functions that return more than one value are commonplace for us, but we are not used to see this kind of constructs in our code. But when you call with a get or a post an HTTP method, when you use an HTTP method, you are getting a lot of values returned. This is a function that is returning to you an error code and a header with a host of parameters, and then a body with a payload full of data. So we are used to deal with functions, with calls that returns a lot of data, not only one value. When you do a select statement in a database, you get the data from the database, and you get a lot of metadata, the number of records, and so on. So this is when you start to use more than one return value. This is really useful, and it's really elegant because you can name the return values. Okay. So until here, surprises. Here in the ifs, the swift way of writing the ifs, this one. You don't need the parentheses, but you do need the curly braces, and you can write functions without putting them into classes. And that is good, and this is good, and we are happy, but we want to write our first class. Are you with me? I want my first class. So
yeah.
Yeah, that's the spirit. I want to see a class and an object. So to create an object, I'm going to create a new playground. So I'm going to close that playground, and I'm going to change my ugly face in the process. And then I'm going to create a new playground called classes. Here inside the Ironhack thing, yeah. And I'm going to change again to the code. You are not here to see my ugly face, you are here to see code. So and try to type code. It's better if you are here to write code. So I'm going to delete everything, yeah. I want an empty playground. I don't need anything, and I'm going to define my first class. To define a class, you use the keyword class, and then obviously you are going to put the name of the class in the. I'm going to create a person class, for example, and I'm going to use a name to put a name inside here. It's a string, obviously, and by default I'm going to assign an empty string to every person's name. Okay? So here I have my first class. Can I use this class? Yes. I can create, for example, a variable called Diego, and then create a new person. To create a new person, you just write the name of the class into parentheses. And as you can see here, I have that object created. I can have a quick look, and I can see that there's nothing inside the object. There's just an empty name, but this is working. I can then use the dot to access that property. This is what's called a store property. A store property is something like an instance variable in Java, and I can put here that my name is Diego. Yeah, as you can see, my object is changing in the right side. You can see my code. Yeah.
Yeah.
Yeah. You don't see the code turn upside down or something like that. You see the code. It looks good. Yeah. You see it right. Well, if you don't see any something, please tell me. Well, we are going to create here classes, and you can put here variables, and you can put here inside methods. For example, I'm going to create a method to print all the data from a person, well, using a pretty print function or something like that. To define a method, you use the same syntax we've been using for the functions. So a method in Swift is just a function that happens to be inside a class. Okay? So a method is just a function I have inside a class. Pretty print. Yeah. Pretty print. So in this case, this is going to print, for example, name. This is not going to be so pretty, but for my example, is going to be good. So here I have a method called prettyprint, and I can invoke it just using my Diego instance. This is an object instance of class person, and I can use Diego dot. You can see I only have two members here, name and prettyprint. Maybe for you this is different because you only have here two members, name and prettyprint, and we are used to have in each of our objects a host of things, because an object in Java or C# or JavaScript always inherits from some other class. In Swift, if you define a class and don't tell here that this class is inheriting from another class, this class is creating an object hierarchy. So this is the first class in this hierarchy. The class person only has name and prettyprint. You can obviously create here a second class called worker with here a constant, let happy, which is a Boolean false, because that's a worker, you know, so it's not happy. And at the moment that the class worker doesn't inherit from anything, but I can make this inherit from person just using the semicolon and then the name of the class I want to inherit. So in this case, if I create a worker right here, yeah, Currito is a new worker. You can see Currito has three elements, has three members here. Happy, which is from the worker class, and name and prettyprint, which came from the person class. If I make the person class inherit from NS object, I need to import here foundation. Foundation is a module, yeah, you can see it as a package, which is analogous to the Java Lang package. It contains basic things for the Objective-C language and for Cocoa. In Foundation, you have the NS strings, you have the NS arrays, the NS dictionaries, you have the dates, you have NS object. So Foundation is, you know, the foundation of the Objective-C, more than the Objective-C and Cocoa framework. Okay, so I'm importing here because NS object is defined inside Foundation. So if you inherit from NS object person, it's going to have more things, and Currito obviously is going to have a lot of things. All these methods came from NS object. Okay, so what are we going to use in our code in Swift? For your model objects, you are not going to inherit from NS object. You are going to define your model object just like this, because you want a clean slate, you want as little overhead as possible. Or if you want to use some of the advanced features that Coco had for NS object, like KVO, key value serving, or key value coding, or something like that, then you can inherit from NS object. But that's optional. It's not like in Java or other languages where if you don't put there anything, you are inheriting from object. Well, you can inherit in Swift only from one class. You can't inherit from more than one class. Okay? So you can only inherit from one class. And you can adopt, you can be conformed to a lot of protocols. A protocol is something like an interface in other languages. It's just a list of effects. So here you can conform, you can inherit just from one class. You can't do that. For example, person, have worker, person, and then NS object. This is not going to work. Yeah? You can only inherit from one of them, and then you can put, you can be conformed to as many protocols as you want. Yeah, just like interfaces in Java. The syntax is using just commas. You just put commas, and then you start implementing interfaces. Here you call it, you are conforming to a protocol. Okay? So now we know more or less how to create a person, but we are going to introduce a very powerful feature of Swift that is copied from Haskell and other functional languages, that is called the optional types. Yeah. Imagine this person, or better than the person, the worker has a salary. Okay. The salary is of type small. I know the type small that doesn't exist, but I think it must be existing. It's of type float, yeah? For example. That's my salary. And when you create a new worker, you don't know really which salary each worker has. So you can pass here something like that. You can tell, create this worker with a default value of 0. But what if you have this thing? You have an intern, yeah, which is of, well, you can put here the worker type, but you can omit it. It's up to you. An intern, most probably here in Spain, in the summer, is going to have a 0 salary. So my question is, if I try to put intern that salary, this is going to be 0 because the object is just created and I haven't changed the salary, or is 0 because the salary is 0 because this is an intern and doesn't have a salary. You get the idea? Sometimes when you have, for example, to position something in a map, for example, a restaurant, and you want to position that thing using the latitude and longitude, you have to create a new restaurant object, and you have a latitude of 0 and a longitude of 0. But 0 are valid values for latitude and longitude. And how can you tell if the object has been just created and not initialized, or it really is in the latitude and longitude 0 and 0? You can discern. So to discern, we create normally here a boolean, yeah, initialized, something like that, true. Or we can create we can put here a negative number, yeah, some kind of stupid value to tell us, hey, the salary still is not configured, yeah. But in Swift we have something more powerful, and these are the optional types. We can define salary to be of a new type. This type is, here you can have two things. So this is not type float. This is a new type called float ? That is being created here for you. For the compiler is creating here a new type, and this type can contain two things: nothing, which is the case here, nothing, or something. But now you can tell that in turn that salary is nothing, so it hasn't been initialized. If you put here that its salary is, for example, 600 euros, you have now some value here. That's what this sum means here. When you use optional types, you are creating a new type, and this type is one of two: nothing, you haven't put anything inside that variable at the moment, or something. And if it's something, you can inspect the value and see the value. You can create optional types for floats, and you can create optional types for your own types. I can create for example, a Groucho, and this to be, and this is so nice because is Groucho a worker? I don't know. so here I have a variable that hasn't been initialized. Yeah, it's called just Groucho, and it contains nil. It contains nothing. That in some time in the future you can construct a new worker, and then boom, Groucho contains something that this is an object that contains everything a worker contains. Yeah, the false value is not happy, and then the nil that comes from, I think, from I don't know where. This nil, I don't know from where it comes.
From the salary?
From the salary, yeah, that's right. Thank you. From the salary. So I can create here Groucho and then assign Groucho that salary. That. What's happening to my keyboard? Yeah, salary. Groucho salary equals. You can see here when you use an optional type, you are here unwrapping the optional type because the compiler has to be sure that inside Groucho there's not a nil pointer. Yeah, so you can tell the compiler, trust me, when this line of code is going to execute, there's going to be something right here, and you can tell the compiler you are sure using this syntax. Here you are telling the compiler, no. I'm sure, I'm 100% sure that in this line of code, Groucho is going to contain something. Or you can still have the question mark, and in this case, if Groucho is not initialized, this is not going to crash. This magically is going to be ignored. Yeah. So the power of optional types is that if you use an optional types that hasn't been initialized, it's not going to crash. This is not going to give you an nil exception. Yeah. This is going just to do nothing. Yeah. That's the no operation. Yeah. So this is kind of cool. If I change this to that, I'm going to have an error in runtime because I'm telling the compiler, no, I'm sure that Groucho contains a pointer, and it doesn't contain a pointer to a valid object. It contains nil. It tries to access the salary and it crashes. Yeah. So uh, optional types, very very important in Swift. You are going to see them all over the place. You are going to use optional types when you can pass two values, when you can pass nil or something. Okay, if you are not sure at first time what are you going to pass to a function, mark it as an optional type and you can pass it nil, for example. And inside the function you can use this kind of syntax just to play with your optional type and to tell the compiler, I don't know if there's something inside here. If there's something, change its salary to 10, and if there's nothing, please don't crash. Just go ahead. Yeah. So enough optional types. We've seen the very 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 basic thing. So I'm going to select here Swift, and I'm going to create an iPhone app. Okay. Here you can choose. Maybe you can see this thing. Well, you can select here between iPad, iPhone, or universal app. If you create an iPad app, it's going to work only in iPads because you are going to design the size of your view controllers of your screens to fit an iPad. If you here select iPhone, this app is going to work in iPhones and also in iPads in compatibility mode. So this is working like a small iPhone app inside the huge iPad screen. But you can hit 1x and 2x buttons and make a zoom to see the iPhone app inside the iPad. If you mark here as an universal app, you should give the Xcode uh, two different designs for your screens. Okay, I'm going to keep it simple and to create just an iPhone app that is going to be created inside the Ironhack folder, and I'm going to maximize this. Can you see anything, or this is too small? Yeah, I'm going to try to stop this thing and then start this thing, and I'm going to, yeah, maybe. Can you see it better, or it's too small? Oops. I'm going to change my resolution then. I'm going to change my resolution. Oh, this is ugly. I'm sorry for all these technical problems. Yeah. Can you see it? And it's bigger. Yeah. Yeah, it's bigger. Can you see it? It's everything is all right. Yeah. Well, this is a shame because I'm wasting my beautiful screen, but at least you can see something. Yeah. Here in my project, it's called Hello World. As you can see here, we have two targets. A target is information for the Swift compiler on which thing it has to make. For example, here we have a target to create a binary, an application, and then a target to run some unit testing. Yeah, to run some unit tests. We are going to use only the target that creates the app, but the other one is here. Here in the Hello World Xcode Pro, which is how you call this file, if you press here with the right button and show in Finder, not this one, but this one maybe. This is in the, this is, well, you can see it because I'm not sharing my whole screen. So here, this is a file that's called Hello World XC project. And here you can change build settings and configuration for your application. For example, you can change which icons are you using for your app, or you can link frameworks, and you can fine tune some things from the compiler. Here we have only two Swift files. Okay, the app delegate is the starting point for our application. I'm going to change this to just presentation. I think this is big enough. And inside Xcode, you can notice we have three columns. Yeah, Xcode has four main panels, four main different zones. Here you have the all the different navigators. You can see the files, or you can see classes, you can search things, you can have a look at issues. Yeah, so these are the navigators. Here you have the main editing area where you have the source code editing and the designers. Yeah, and here you have the other panels that shows you more information. For example, quick help, or here you have buttons for add objects to your designs. The app delegate is a class that's in each and every single iOS app, and is the entry point for your application. In this case, we are using this function, this method of our app delegate. This is the class app delegate, which inherits from UI responder, and it's conformed to the UI application delegate protocol. So this is an interface. Yeah. This method is going to be called by iOS when our application is fine, is running, has memory, and Coco has finished initializing all the memory it needs, all the things it needs to work. So here you can do whatever you want. For example, you can print a log. You can, for example, print hello world. And then after doing this line, we are going to tell iOS we are good to go with this return true. And iOS, in this case, is going to launch the first screen in our application. The first screen in our application is defined inside this main storyboard file. Okay? This main storyboard file is used because in our project, our Hello World project, we are telling our target to use, as you can see here, as our main interface file, the main storyboard. We can have more than one storyboard. We can change it here, and or if we rename it here, we can change it again here. So our app, when it starts, looks up in the main storyboard file and looks for screens. Yeah. A screen inside a storyboard is called a scene. Yeah. In this case, this view control scene is a view controller. A view controller, you can think of a view controller like a screen, yeah, or an activity in Android if you do some Android development. So here we have a view controller, and as you can see, well, you can't see it. I'm going to zoom to the 50%, yeah, and finally you can see the view controller, yeah. This view controller is a fat view controller, is resizable, and it doesn't look like an iPhone screen. This is because Apple is preparing us for different width and height iPhones in the future, or maybe apps for the Apple TV. And I think no one knows what's going to happen. But we can change. We can simulate here that that this view controller. Remind me later. Uh, Install updates. I don't want to install updates. Yeah. So this view controller, we can change the size and use an iPhone, and this looks more like an iPhone. Okay. The view controller, which is our screen, contains a view. This view is white because the background color here is white, but we can change the background to another color, for example, green. Or I'm going to use a darker shade of gray. Yeah. Once we have here a different color, we can start adding objects to our design. We can add, for example, controls. The controls we can add to a view are white. And the special objects, view controllers or gestures or special objects, are yellow. So quick way to differentiate them, if they are white, you can add to a view. They are widgets. So I'm going to add here a label. Yeah. You can create a label. You can design changing here the text. And you can change some properties. Not all of them, but some of them. I can center this thing. I can move around, and you can see the blue guidelines. This blue guidelines helps you aligning things in the screen, and also they are warning you when you approach one of the edges of the iPhone. If you approach the edge of the screen, they are telling you you are going to print, for example, in the notification area, and with the time and the battery, and hello world is not going to be seen. Yeah. So I'm going to move the hello world thing. I just hope to move it. I'm going to change this font a little bit, and you change the color, and so on. After we've played with the label and we are happy, we are going to add a button that looks like anything but a button. Buttons in iOS, since iOS 7, doesn't look like a button. I don't like it, but I'm used to. But I think a button is a button, a label is a label. But we are flat now, so we are going to put here a push me. Yeah, that's a push me button, and I'm going to run my super app. Okay, and I'm going to as I've changed my as I've changed all the resolution, I'm going to share the whole screen. Okay. Well, I'm going to run my app in an iPhone 5, for example, or 5S simulator. When you hit Command R is the the combination of the command and run. And well, I'm used to just press Command R and not pressing the play button. Well, here we have our app in all its glory. This app is showing in the simulator, but the simulator is too big for my screen, so I have to scroll. Well, I can change in simulator here the zoom scale, and I can scale it to 50%, to make it fit my screen. As you can see, I have here my label, and I have here my push me. Yeah. You can see here I have another hello world. This hello world came from the app delegate. The application did finish launching with options. In this function, I'm printing this hello world. Okay? Well, I want to do one thing with my app. I want to print something. When I click push me, I want to print here clicked. Yeah? We are going to try that. It's super simple. To do that, we need to add code to the other Swift module we have here. We have a view controller Swift class, and this view controller Swift class is the class that contains all the code that responds to the events in our view controller in our scene. So in iOS, you have storyboard with the graphic scenes. So here you have all the graphic things, all the design, and you can have all your code inside your view controller. Okay, so this view controller is linked to my scene through this view controller object. So this design is bound to my view controller class, as you can see here. They are bound, so I can hide the debug area, I can hide the navigator, and I can split my screen in two. With the assistant editor, you can split your screen in two. Splitting your screen allows you to, for example, do things like this one. If I want to respond to a push, I just have to press and hold the control key, not command, control key, and then click and drag to my code. You can see here Xcode recognizes the design of my screen and the code of my screen are related, and it's going to make me a connection. If I release this thing, I can select the kind of connection. If I create an outlet, I'm going to have here a variable that points to this button. So I can use that variable to, for example, change the text of my button or the color of the button. But in this case, I don't want an outlet. I want an action. I want to respond to the clicks. And when you click, I'm going to be Captain Obvious, and this is going to be called button click. We are not going to receive any arguments. And you can see here, I have a function. This is a normal method. It's called button click. It doesn't return anything. It doesn't receive anything. And it's marked with an IB action, a funny IB action thing. This is telling Xcode that this is connected with something here in my design. And you can hover, you can move your mouse over this target thing, and you can see that this thing is connected to my button. Here, I can just write my print. I've been clicked. And if I run this again, I stop and run. This is compiling, it's good. If I push, you can see here, I have a bunch of I've been clicked. So this thing is looking good. Do you want that we add an image to our application? Yeah, I'm going to add just an image. Yeah, and maybe we can finish with that. And do you want it? Yeah, I'm going to do it anyway. So I'm going to add here an image to my design. My design has changed. I don't know why. the orientation. I want the orientation in portrait. Yeah, that's better. This is a beta. Yeah? And I'm going to use an image view. An image view is a control that can show images. Okay. So to show an image, I'm going to show an image I have inside my project. Okay. So to show an image inside my project, I need images right here. I'm going to add an image to my project. I'm going to download from the internet. For example, I'm going to use the sad Batman meme. Yeah, I'm going to use this one, for example. I don't know if you know this meme, but this is huge. I'm going to use this image. Batman is not able to to mount this this wardrobe. Yeah. So I'm going to use this Batman JPEG, and I'm going to add to the images XCSS folder. This folder helps us organizing our images. So we can just drop images here. I have a Batman. This Batman image is Retina display ready. In an ideal world, you have here 2 versions, especially for iPads. But I'm going to use this as Retina. And I'm going to show this Batman image when you click the button. Okay? So the idea is when I click the button, I'm going to show here a Batman image. Okay? To do that, I will need to respond to the click. I'm already responding to the click. And I need to access this object. To access this object, I need some kind of variable inside my view controller class. To do that, I'm going to split my screen, and I'm going to create here a property. To create the property, I'm going to press and hold Control again and to Control drag. And I'm going to insert, in this case, an outlet. Remember, outlet is a variable. And with this variable, you can read or change the contents of the object it's pointing to. So I'm going to call it Batman image. Going to connect it. You can see this is different from this one. This is an outlet. Yeah, this is connected to my image view. And when my button is clicked, I need to access Batman image, access its image property, and assign some image. I will need to define an image in memory, a bitmap. It's called in Cocoa Touch an UI image. So this is my var image. It's an UI image, nil, and I need to load this image from a file. So to load this image, I'm going to create this image right here using one constructor UI image has. This is an object, so I'm going to construct it using one of these constructors, and it has one called UI image named. Named is the name of my image. I think it's called Batman. Is that all right? This is called Batman because inside my images XCSS, this is called Batman. So I've just connected my image view here, and I'm telling my button, when I click my button, print I've been clicked, load an image in memory using the file in this called Batman, and then assign that image in memory to the visible image of this UI image view. I'm going to run this thing, and I hope pushing boom. Here you have it, loaded from this. As you can see, this is very, very easy. And I hope with this 2 hours, you get an idea of what Swift has to offer to us. Um, to wrap the session, remember, Swift is not a finished language. Swift is changing with each Xcode beta. Swift is advancing, and Apple, incredibly, is listening to his developers. So Apple is listening to the developer community and is making changes very, 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 very quickly to adapt to errors or missions, or to change things to make Swift a better language. I just encourage you. I I will be more than happy if you join any of the meetups, of the local meetups you have there in Barcelona. In Barcelona, you have a very vibrant iOS development community. I know a few of them. They are quite good, and they explain better than me. So I really encourage you to try to find your local community. I think I see one of them right there. So uh, hi Uri, yeah, say hi, yeah, hi, hello. So so yes, ask Uriel, and he will point you to the vibrant community of iOS developers there in Barcelona. So nothing more. Do you have any questions, or we can go and have a beer? Well, I will I will have a beer on my own, but you know, thank you for your time, for all the heroes that are here, and at 9 o'clock in the evening, instead of being on the beach or having a beer. So thank you very much for your time and your attention. See you soon at the NS Spain conference. Uh, Hope to see you all there in Logroño. Yeah, yeah, in a month's time. So it's near here. Yeah, see you in Logroño. Yeah, bye.